Hey guys, welcome to this review of Chapter 11, where we're really just going over the first four lessons: inverse functions, rational functions, simplifying rationals, multiplying and dividing rationals. Let's take a look. Number one, which equations are inverse functions? So first off, an inverse function either looks like xy equals k, or it can be in the form of y equals k over x. They mean the same thing. Xy equals -6 definitely looks like my first example. X divided by y equals 4? Nope, it's not one of those examples. Y equals 3 over x. Yep, that definitely looks like my second example. And y equals -8x. Nope, that's actually a direct variation. It would be a linear equation. Number two, the set of ordered pairs is for what? Inverse function. So if I know that this is an inverse function, that means when I multiply x and y together, I get the same k value. 1 times -3 is -3. 3 times -1 is -3. -1 times 3 is -3. I think you get the point. Whenever I multiply these x and y values together, I get -3 as my answer, and that would be my equation. Now, I don't see xy equals -3 in my list, but I do see it in its other form. If I was to get y by itself, this would look like y equals -3 divided by x, which is actually my first answer. Number three, the graph of which inverse function is shown. This looks good. Now, if I wanted to be able to tell from a graph which inverse function is it, maybe I want to make like a table of values and see. Like when I look at this first graph, I see that, the curve on the top right has an ordered pair of 1, 4. I also see a point of 2, 2, and I see a point at 4, 1. Now, it should be pretty obvious right away, right? If I look at this, if I was to multiply my x and y values together, each time I get 4, which means that this equation is simply xy equals 4. Even if I look at the other table of values for the bottom left-hand curve, I would have, my first ordered pair is at -4, -1. Then I have -2, -2, and I have -1, -4. And if I multiply those across, I get 4 as well. So xy equals 4. Number four, if y varies inversely as x and y equals -8 when x equals 2.5, find y when x equals 4. So basically, since x and y are supposed to multiply to get the same answer, if I take the first values, it says when y equals -8 when x equals 2.5. So basically, if I multiply those two together, I'm going to get my value for k. So if I do 2.5 times -8, I get -20. So that means x times y should be equal to -20. So then if I do the second part of the problem, it says find y when x equals 4. Well, if x equals 4 and I need to solve for y, 4 times what is -20? The answer is -5. And so since 2.5 times -8 is -20, 4 times -5 would also get me that same answer. I know it says find y and I have x equals. My apologies on that. Excluded values are the value of x that make the denominator. Let's see, you are not allowed to have a denominator that is ever equal to 0. So here, if I just have this where it says y equals 2 over x, x is allowed to be any number in the world except for 0. Because if it was 0, I can't do 2 divided by 0. But x can be 1, x can be 2, x can be -1, x can be -2. It just can't be 0. Number six, what's the excluded value for this function? So basically all I'm doing is I'm going to take this function and I'm going to say, hey, what is x not allowed to be? Because it would make my denominator 0. So I'm really just setting my denominator of x minus 5 equal to 0 to kind of figure out, hey, what is it not allowed to be? And that gets me x equals 5, which actually means x is not allowed to be 5. Now think about it. If x was 5, if I plugged 5 in, what's 5 minus 5? 0. And you're not allowed to have a denominator of 0. And so that's my excluded value. X is not allowed to be 5. Now, when you have more than one variable, x squared y to the third, and I'm asking for excluded, well, I can't have values that make the denominator 0. And 0 times anything is 0. So x is not allowed to be 0, and y would not allowed to be 0. They could be any number in the world except for those values. Now, number 8 is also a really good problem, right? Find the excluded values. Remember, we only care about the denominator. We only care about the fact that the denominator cannot be equal to 0. So if I want to find my excluded values, I set my denominator equal to 0. Now, I do have to remember this is a special binomial. It's a perfect square minus a perfect square. This gets factored as x plus 4, x minus 4, which actually means I have two excluded values. X is not allowed to be negative 4, and x is not allowed to be positive 4. So I'm going to select both of those. Number 9, identify the asymptotes of the function. So we were studying this function for rational functions, f of x equals a over x minus h plus k, where h is my vertical asymptote and k is my horizontal asymptote. And remember, vertical asymptotes are x equals equations, horizontal asymptotes are y equals equations. So when I give you f of x equals 3 over x plus 5 and then plus 1, I know that my h value, h equals negative 5. So that means my vertical asymptote is x equals negative 5. That would be the vertical line that sneaks in right between those curves. And then my horizontal asymptote is my k value. So since my k is 1, my horizontal asymptote would be y equals positive 1. So negative 5, positive 1. When I show you a graph, I should be able to see, my vertical asymptote. Okay, my vertical asymptote here. Now I need to find my asymptotes to be able to figure out my equation. So here I can see that, my vertical asymptote is at x equals 3. X equals 3 is the vertical line that cuts right through. My horizontal asymptote is y equals, and I can see that this one would be negative 2. Now that really means that my h is 3 and my k is that negative 2. Now, when I look at the function, f of x equals a times x minus h plus k, and I plug those numbers in, I would then be looking at f of x equals, I'm just going to call my a value 1. It looks pretty standard. X minus, what's my h? 3. And then what's my k? It's minus 2 at the end. So I'm looking at 1 over x minus 3 and then minus 2. What's the equation for, this one should say what are the asymptotes for this graph. So I had my directions mixed up. So this one I could see that it has an x equals 3 and a y equals negative 2. It's actually the same exact graph. Just my questions are switched. All right, starting at number 12, we are simplifying. So simplifying requires factoring. And simplifying then requires you to not only factor, but for you to simplify out what they have in common. So we have to know, when I look at this first trinomial, x squared plus 8x plus 16, what two numbers multiply to get 16 that add up to get 8? It's 4 and 4. So that would be x plus 4, x plus 4. And then when I look at my denominator, x squared minus 16, a perfect square minus a perfect square, that factors as x plus 4, x minus 4. Now, the beauty of this is that whatever you have in common in the numerator and the denominator, you get to simplify out. So x plus 4 simplifies out with an x plus 4. Look what I'm left with. It's just x plus 4 over x minus 4. And I know you may feel like you want to simplify this further, but you can't. It's a binomial over a binomial, and we are done. Number 13, when you multiply or divide rational expressions, you want to factor the numerator and the denominator to find factors that can be simplified out. Well, that's exactly what we did. The answer is true. Let's do some more simplifying now. Ready? We have x squared minus 4x minus 5 over x minus 5. I can factor that trinomial. That trinomial is x minus 5, x plus 1, right? Because if I ask you what two numbers multiply to get negative 5 that add up to get negative 4, it would be negative 5, positive 1. Notice what these have in common. They have an x minus 5, x minus 5, and so I'm actually just left with x plus 1. That's it. Next one, if I have x plus 7 over x squared minus 49, well, this gets factored as x plus 7 over x plus 7, x minus 7. Now, when I cross out x plus 7, what's really left in my numerator? There's really a 1, right? We know that there's a placeholder of 1. And so my answer is 1 over x minus 7. More factoring, ready? X squared minus 64 over x squared plus 9x plus 8. Okay, so x squared minus 64 becomes x plus 8, x minus 8. What two numbers multiply to get 8 that add up to get 9? That's a positive 8 and a positive 1. What do I get to simplify out? X plus 8, x plus 8. And there's my answer, x minus 8 over x plus 1. More factoring. 5x squared minus 15x over x squared minus 6x plus 9. Now, my numerator, that's not a perfect square minus a perfect square, but I can factor out a GCF. Like, what's in common between those two terms? It's 5x. Now, if I factor out a 5x from both of those terms, I'm left with x minus 3. Now, my denominator, what two numbers multiply to get 9 that add up to get negative 6? It's negative 3 and another negative 3. Now, when you simplify out, it's a 1-for-1 deal. You can only cross out one on top, one on the bottom equally. So an x minus 3 on top crosses out with one of the x minus 3's on the bottom. You can't wipe out all of them unless the other x minus 3 had another x minus 3 on top. And so this is my final answer, 5x over x minus 3. Okay, last few problems here. Lots of factoring, but it's all good factoring so that we can simplify things out nicely. All right, times x squared minus 36 over x squared plus 8x plus 7. All right, let's factor this. X squared minus 49, that becomes x plus 7, x minus 7, over, what two numbers multiply to get 12 that add up to get negative 8? That would be a negative 6 and a negative 2. Times, all right, over here, x squared minus 36. Well, that would be x plus 6, x minus 6. What two numbers multiply to get 7 that add up to get 8? Positive 1, positive 7. Let's cross out x minus 6, x minus 6. What else do you see? X plus 7, x plus 7. Everything I have left over here doesn't have a match, and that's actually my final answer. And it looks like it's the last one on my screen. Next one, same skill. Ready? So x squared minus 25 over x squared minus 10x plus 25 times x minus 5 over x squared plus 10x plus 25. Oh, lots of multiples of 5 here. Okay, you guys, first numerator, x squared minus 25. That's easy. X plus 5, x minus 5. What's x squared minus 10x plus 25? What two numbers multiply to get 25 that add up to get negative 10? They're both negative 5s. This numerator doesn't have to be factored. What two numbers multiply to get 25 that add up to get positive 10? X plus 5, x plus 5. Lots of repeats here. It's a 1-for-1 deal. Ready? So if I cross off an x plus 5 up top, I get to cross one of them at the bottom. I can't cross out anymore. What if I cross out this x minus 5 on top? I can cross it out with another x minus 5. But look, there's actually another x minus 5, x minus 5. Those can also be gone. So the only thing I'm left with is an x plus 5 in the denominator. What's technically in my numerator? A 1. And so my final answer is 1 over x plus 5. Last question. The only difference is it's a little division. So we just have to remind ourselves about the rule about dividing fractions. But then once we are good, we are just simplifying out what we can, and we're going to get a beautiful answer. Okay, so first off, we divide fractions by multiplying the first fraction by the reciprocal of the second fraction. And I have some factoring to do here. So first off, my first fraction stays the way it is, but we can factor it. What two numbers multiply to get 81 that add up to get negative 18? It's negative 9, negative 9. 4x plus 36, not a difference of squares, but I could factor out a 4. And if I do that, I'm left with x plus 9. We then multiply it by the reciprocal of the second fraction. So I have to take this fraction, I need to flip it. So that actually means 2x plus 18 goes up top. But can I factor 2x plus 18? Yes, I can factor out a 2, and I would be left with x plus 9. And then x squared minus 81 actually goes to the bottom, but I can factor that. It's x plus 9, x minus 9. Lots to cross out here. So an x minus 9 with an x minus 9. An x plus 9 with an x plus 9. Doesn't look like anything else matches up beautifully. And so let's see what we have here. We're left with 2x minus 9 over 4 times x plus 9. Now, the only last thing I can actually do here is, what does 2 over 4 simplify to? That becomes 1 over 2. And that would be my final answer. So it's actually this answer here, x minus 9 over 2 times x plus 9. I hope this review was helpful. Good luck on your test. Bye.